Let's start with some introduction. My name is Greg Driskell, and I am the president and founder of Professional Pavement Products, a 20-year young company providing products, services, and solutions for the pavement maintenance, marking, and construction industry for over 20 years. I have over 25 years of experience in the roadway safety, maintenance, and marking industry, first as a contractor and then as a supplier. I'm involved in product and specification development. We're active in the industry associations such as American Traffic Safety Services Association, American Public Works Association, Institute for Transportation Engineers, and many more. We also contribute to trade publications such as Pavement Magazine, Entrepreneurs Magazine, APWA Reporter, Roads and Bridges, and more. Now, let's get started.
Hello, and welcome to Retroreflectivity 101. Today's topics are retroreflectivity and the instruments that are used to measure it. Under retroreflectivity, we'll talk about what is it, why is it important, and what are the differences. For instruments, we'll discuss why use them. What are three factors that should be considered? What three categories do the instruments fall under? And lastly, what critical data is necessary? So let's get started with what is retroreflectivity? What is retroreflectivity? Most simply is the ability of an object, like a stop sign, to redirect the light back to the source, like the vehicle. On to the next. Why is retroreflectivity important? Why is retroreflectivity important to the roadway safety? Well, first of all, driving at night is more dangerous. At night, there are very limited visual cues that help the driver navigate the roadway, and the decline in older drivers' vision. Nighttime is more dangerous. In the United States, statistics show that you are 3 times more likely to die in a fatal accident at nighttime rather than daytime. At nighttime, there are limited visual cues to help navigate the driver through the roadway system. During the daytime, we have many cues, like trees, buildings, and the pavement itself. But at night, we can only see what reflects back to us from the light of our vehicles. Retroreflectivity provides nighttime guidance for motorists. Then there's the decline in older drivers' vision. Here in the United States, like in many nations, the population is aging. By 2030, the U.S. population of those 60 years old will double. How does it look for your state? And why does it matter? As we get older, we need more light to see. This represents how a 20-year-old would see the street. This as a 60-year-old would see the street. And this as an 85-year-old would see the same street. Our need for light for proper vision increases dramatically as we age. By age 85 years, we need 32 times more light to see as a 20-year-old does. Now let's discuss what is the difference? What's the difference between materials, units, angles, and instruments as we begin to dive deeper into the measurement of retroreflectivity. So how do we measure retroreflectivity? Well, this depends greatly on the type of device that we're measuring. Different devices like reflective pavement markers, pavement markings, and signs all use different retroreflective materials. Different devices are seen from different angles and different heights Therefore, measurement angles, formulas, and units all differ. These devices must be measured by different instruments. Let's first discuss the different materials. Before we do, we need to better understand how light reflects. When light hits an object, it will naturally reflect in the opposite direction by the same angle. But retroreflection is when the light hits an object and returns back in the same direction. So how do we break the laws of physics and get the light to change its direction? In pavement markings, we use the refractive capability of glass beads. We partially embed them into the pavement marking material to about 55 to 60% depth. As the light comes from the source, the vehicle's headlights, it bends and refracts at the point of entry of the glass. The light reflects off the back of the glass bead, taking the binding material's color with it. Then the light bends and refracts again at the point of exit of the glass and returns the light back to its original source, the driver. For sign sheeting, we use two primary methods. First, like the pavement markings, we use glass beads. The vehicle light strikes the glass beads embedded into the sheeting, bends, reflects, and then bends again, returning the colored light back to the driver. Second is the use of prisms, microprisms. The vehicle's light strikes the microprismatic surface embedded into the sheeting. It reflects on multiple mirrored surfaces and returns back to the driver. Microprismatics are also used in reflective pavement markers. Now let's look at the different measuring units. Generally, retroreflectivity is measured in candelas. A candela is basically the light of a candle 1 foot from your face. A millicandela is, of course, 1/1000th of a candela. For highly reflective devices, like sign sheeting, we use candelas. For lesser reflective materials, we measure millicandelas. Now let's look at measuring different angles. When we look out our windshield, we see these devices in various positions. Reflective pavement markers are down and to the sides. Pavement markings are down in nearly all directions. For these, light goes down and comes back up. Signs, though, are up and to the sides. The light goes up and across and comes back down and across. So each device is struck by the light at a different angle and observed from a different angle. We call that entrance and observation angles, requiring different measurement formulas to account for the different angles. Now let's talk about the different measuring instruments. But first, we might ask, why use instruments? Why not just visually inspect them? First, visual inspection requires a person to inspect under the right conditions. For example, this is what these signs look like during the daytime. By this picture, can you pick out the signs that are retroreflective and the ones that are not? Likely not. You could only visually inspect in nighttime conditions. Here's another example. This is what the markings and signs look like in the daytime. This is what they look like at night. There's a big difference, isn't there? And this is what they look like in the rain. Notice here that the marking on the right-hand side is specially designed to provide retroreflectivity in the rain. Lastly, and most importantly, remember that we all see differently. And how we see is greatly affected by our age. Remember, we need more light as we age, so we would all see different levels of retroreflectivity. Okay, now let's start taking a look at the instruments themselves and why we use them. Why we use instruments is because they produce a reliable scientific measurement that eliminates human error or subjectivity. They're safe. They're a safe method that allows for inspection night or day during the safest time of that particular roadway. They are relatively easy to use, not requiring special ages or visual inspection training or experience. And of course, they save money, eliminating unnecessary replacement of pavement markings or signs. And lastly, they save time. They save time by viewing, assessing, and recording accurate measurements with a push of the button. Now let's move on to the 3 factors that affect retroreflectivity measurement. There are 3 primary factors in using retroreflective instruments. You must have a quality instrument, operate it properly, and record the right data. Next is the 3 categories of retroreflectivity equipment. Due to their very specialized technology, there are only a few manufacturers of retroreflectometers around the world. They're made in places like Germany, Denmark, Brazil, and ours is made here in the United States. I want to mention here that the instruments information provided in the next slides are meant to generally represent most all instruments and are not necessarily specific to ours. It does not show the specific features. We can categorize these instruments in many different ways, but for this presentation, we'll put them in a category based on how they're used. I'll start with handheld units. Then we have mobile units. Now, both handheld and mobile are used as field instruments. And then there are laboratory instruments. There are handheld instruments specifically for signs and for pavement markings and for RPMs. There are mobile devices for pavement markings, and then laboratory instruments that can measure retroreflectivity on most all devices in the laboratory condition. So what instrument do you use? The handheld sign retroreflectometers are used to measure the retroreflectivity of traffic signs in the field. These devices measure the retroreflectivity of a selected area of the sign. So how are handheld sign retroreflectometers used? How do they work? How do we operate them? Well, first, you place the instrument flat against the sign and you pull or trigger or push a button. According to the ASTM standards, you measure 4 sample areas of the legend and 4 sample areas of the background, totaling 8 measurements for the average sign. We use the average of the 4 readings. We do not measure black. To get more accurate readings with a pointed device, you should measure both a horizontal and vertical reading of each area and average them on prismatic materials. This increases you to 16 readings per sign. The 922 shown here uses annular technology, eliminating the need for horizontal and vertical measurements. Note that there are different retroreflectivity requirements for the different colors. So what about mobile sign retroreflectivity? Mobile sign retroreflectivity of signs is being worked out and worked on, but cannot be achieved using the current ASTM standards, as they require entrance angles that actually do not exist in the field. Even if we change the standard, we will have to deal with the variance in sign placement, types, sizes, colors, and shapes. It will be difficult to get an accurate measurement. The first generations of these will be best used to determine which signs need handheld retroreflectometers to be used on them. Now let's look at pavement markings. The handheld pavement marking retroreflectometer is used to measure pavement markings in the field. These devices take a single measurement at a time of a small specific area of the marking. Therefore, it's best used for smaller pavement marking applications, like intersections and turn lanes. It's also good for smaller government agencies that want to confirm the quality of their contractors' work. So how do you operate a handheld pavement marking retroreflectometer? Place the retroreflectometer squarely on the marking in the direction of the vehicular travel. Make sure the marking is across the entire reading area. Pull the trigger or push the button, taking a single measurement. There are various testing procedures throughout the United States. Most require only an average of 3 or so measurements per section and per line type. That section could be up to 1 mile long. Like with signs, there are different retroreflectivity requirements for different colors. And then there's the handheld reflective pavement marker retroreflectometer that's used to measure RPMs in the field. These devices take a single measurement at a time of an individual retroreflective pavement marker. These provide the advantage of not having to remove the marker from the pavement and measure it in a laboratory, better representing how effective the marker is on the roadway. Some brands, like this instrument, the Road Vista 1200F, are designed to be used either in the field or laboratory conditions. So how do we operate the handheld pavement marker retroreflectometers? Similar to the operation of the pavement marking retroreflectometer, you place the retroreflectometer aligned properly with the pavement marker. Remember, the measurement angles include left and right offset, so the marker must align properly in the measuring area. Pull the trigger or push the button. The machine reports the measurement in the appropriate angles and units. Like other materials, different colors have different expectations and requirements of retroreflectivity. The mobile pavement marking retroreflectometer is used to measure large quantities of pavement markings in the field. These devices take between 25 and 400 scans per second, allowing the measurement to be taken from a moving vehicle, making them great to test newly applied markings or determine the condition of existing markings on a large roadway system. So how do you operate a mobile pavement marking retroreflectometer? Well, mobile devices and their operations vary quite differently from one to the other. But the basics is that the device is attached to a vehicle at a specific height and angle. The device is operated by electronic equipment like a computer. Some, like the LLG7, can be operated by a tablet or even a cell phone. Once activated, the marking is scanned or photographed at a rapid speed. The LLG7 at 400 scans per second, others at about 25 scans per second. Note that the newer generation mobile retroreflectometers will also measure pavement markers. The geometry is different, so it's not a direct comparison for retroreflectivity to the handheld standards, but is a quick way to locate poor performing, missing RPMs by geotagging them. Lastly is the laboratory instrument. These devices are capable of measuring most any device, including sign sheeting, reflective pavement markers, pavement marking tapes, all in a controlled laboratory environment. Laboratory devices must be operated by a very skilled laboratory technician. This instrument is set up in a darkroom, we often call a tunnel. This eliminates any chance of stray light interfering with the measurement. The light source and detector are set up at one end of the room and the object being measured at the other end of the room. The object's angle and position are precisely managed by the goniometer's computer. These instruments are very accurate but cannot measure the devices in the roadway environment. Last on our agenda is critical data. What data points, what data information should be collected with your retroreflectometer? In the end, it's all about the data. After all, the sole purpose of taking measurements is to gather and analyze the data. What data should you expect from most all types of retroreflectometers? Most importantly, the data must be accurate. It must be material type specific, have the correct angles and calculation, and adapt to various materials and colors. The data must be comprehensive. Data like the measurement location, usually a GPS or barcode is used, or both. The project or roadway name, the time and the date, and even the temperature and humidity. The data must also provide information on the type and condition of the sign, line, or marker. For signs, we need the sign type, such as a stop sign, a speed limit sign, the sheeting type. Is it a prismatic material? Is it a type 1, type 2, type 3? Is the sign damaged? And which direction the sign is facing, as this often affects its durability. For pavement markings, the data should provide information on the color, the material type, the width or type of marking, if there's any damage, and the road surface type. And lastly, the data should be transferable, easily transferable for further analysis. It should be in common file types, such as CSV for easy export to Excel and other programs, or KML files for mapping programs such as Google. The instrument should connect easily. Use of USB, Bluetooth, Wi-Fi, or data sticks are most commonly used.
And that brings us to the end of our Retroreflectivity 101 webinar. Thank you for attending. If you have any questions regarding retroreflectivity or any of the other products or topics that we have at Professional Pavement Products, feel free to contact me directly at greg.driskell@pppcatalog.com. That's greg.driskell@pppcatalog.com. Also note that we have more free knowledge share at pppcatalog.com. Just follow the Knowledge tab to the Knowledge Center. There you'll find plenty of information and educational pieces for you and your department. Thank you, and have a great day.